Hello everyone. Hello lovely students. Welcome back to this video session. Hope you all are doing great in your life. My name is Ashwan and today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So for today's session, we have got this question and we have to find the range of this functional expression. And I request you all to pause the video, read this question carefully, and try to solve it on your own. All right, now let's solve this question with me. Okay, uh, let's name this functional expression as fx. So we have fx is equals to the square root of 4 sine square x minus sine of x plus 3. Okay, now let's concentrate on the inside functional expression of the square root sign. Let's rename it using g of x. So we have fx is equals to square root of gx. Now first of all, we'll find the range of g of x and then we'll take its square root. That will eventually give us the range of fx. Okay, so let's write gx once again. So gx is 4 sine square x minus sine x plus 3. And this expression of gx looks very similar to a quadratic expression, isn't it? Now, many of you would be wondering, how can I say this a quadratic expression? Well, if you substitute sine of x is equals to t, okay, and you put the value of t, sorry, if you put sine x is equals to 2 in this expression, you have 4t square minus t plus 3, and this is a quadratic expression. Now, whenever we come across a quadratic expression and we need to find the range of that quadratic expression, it is advisable to use a special technique. Can you guess what's that? Many of you might have got the answer. Yes, absolutely right, my dear friend. It's the square completion process that we're going to use here for finding the range of this quadratic expression. And in my previous video, I have given you a little idea about how to make a perfect square when you are given a quadratic expression. I'll repeat it once again for you all. So perfect square means, let's say you are given something like p square plus q square plus 2pq. So if you come across this type of situation, you'll immediately understand because it's very simple and you write p plus q whole square. But every time the expressions that you come across in maths are not very simple. So let's suppose if you come across some expression, I'm just representing it using e of x. E of x is some expression and it's quadratic in nature. Quadratic in nature. Okay. So you can make it a perfect square that I'll tell you in a short while. But when you make it a perfect square, when the expression is not simple, you'll get a whole square. And in addition to the whole square, you'll get some extra term. And let's represent using something. So now something will be some expression, some number or anything that depends on the situation. Now, let's just concentrate on doing the perfect square. So if you have AT square plus BT, okay, once again, I'm telling you, I have discussed this in detail in my previous video. So to those students who are watching this video session for the first time, I request you once again, please watch my previous videos where I have discussed in detail about the various techniques of finding the range. And also I have talked about the square completion process. Okay, so if you watch those videos, you'll understand in a much better way. So let's get back here. We have AD square plus BT. We take A common. In the bracket, we are left with T square plus B by AT. Now, to this B by A, okay, we multiply it by half to get B by 2A. And we'll use this B by 2A. And we also square this B by 2A to get B square upon 4A square. Okay, now with the help of these two entities that we just obtained, we can write AT square plus BT is equals to 8 times. In this place, we can write T plus B by 2A whole square minus B square upon 4A square. and you have to memorize this, okay, to save your time, because most of the times, again and again, you'll come across this type of situation. Okay, so if you know this, you can directly write without any further simplification. Okay, so many of you would be thinking that we are given AD square plus BD, and I have written this. So if you have some doubts in your mind, you can simplify this expression, and you will again get this AD square plus BD. So in maths, most of the times, we modify a given functional expression for the ease and for the convenience of our solution steps. Okay, so using this logic, let's get back to our solution area. So we have 4d squared minus t plus 3, and let's write it in a way so that we can easily see the values of a and b. So we have 4d squared, and for negative t, we can write negative 1 into t plus 3. Okay, and the value of a is 4 and the value of b is negative 1. So we write a times t plus b by 2 into a, the value of a is 4, whole square, minus b square upon 4a square, a is 4 square, and so we have 4 into t minus 1 by 8 whole square minus 1 by 64. Now this is your gx, and we back substitute the value of t as sin x, so we have 4 times sin x minus 1 by 8 whole square minus 1 by 64. Okay, so we find the range of this functional expression, which looks a little bit complicated and scary, but don't worry, we'll do that. Okay, so we start with sin x, the basic trigonometric function whose range is negative 1 to positive 1. Okay, now we'll modify this basic trigonometric function after every step to get a new function. Okay, so when we add negative 1 by 8 to sine of x, so the new range will be, we add negative 1 by 8 to the left hand boundary point and negative 1 by 8 to the right hand boundary point. That will give you negative 9 by 8 to 7 by 8. And I want to remind you all that after modifying the given basic trigonometric function at every step, we'll eventually create this expression that will give you range in return. And in my previous videos on finding on various ways of finding the range of a modified functional expression when a given basic functional expression is given to you, I have discussed in detail. So I request you all to watch my previous videos so that you can understand in a much better way. All right, now let's get back here. So we have sin x minus 1 by 8. Now we square. So when we square sin of x minus 1 by 8, we are squaring this. Okay, we are modifying after every step. We are doing the modification after every step. We are given some functional expression and we are modifying it after every step. I'm repeating it again and again so that you can understand it in a much better way. So sin x minus 1 by 8, we are squaring. So when we are squaring, that means we are squaring all the elements present in the range of the above functional expression. So when you square, the new range will be 0 to 81 upon 64. Okay, 0 to 81 upon 64. And there is a logic why I'm directly writing 0 to 81 by 64. Because if you draw the number line, you have 0, and on the right we have 7 by 8, on the left we have negative 9 by 8, and negative 7 by 8 would be somewhere over here. Now when you start doing the squaring of all these numbers of the number line, you know, you'll get 81 by 64, you'll get 49 by 64, you'll get 0, and you'll get 49 by 64 again. Let's also represent positive 1 by 2 and negative half. Okay, so when you do the squaring, you get 1 by 4, you get 1 by 4. So you can see here for all the numbers from negative 7 by 8 to 0 and 0 to 7 by 8, when you do the squaring, you'll find, you know, the numbers will repeat. So instead of taking the right hand side for the squaring process, it's sufficient that we take only this portion, okay, from negative 9 by 8 to 0. If you square all the numbers from negative 9 by 8 to 0, you get all the elements that are supposed to be taken for the range of sin of x minus 1 by 8 whole square. Okay, and there is a logic as well. logic says that if you have some expression, okay, if you have some expression E of x whose range is let's say P and Q. Okay, P is negative and Q is positive, and mod of P is greater than Q. Then to get the range of E square x, okay, we are squaring this expression. So the range will be 0 to P square simply. Okay. So no, we have used the same logic here. So now we have 0 to 81 by 64, and now we modify it further by multiplying it with 4. Okay, in the original expression, we have 4 here. So we multiply it by 4, and the last will add negative 1 by 64. So we multiply it by 4. But when we multiply it by 4, let's represent sin x using symbol small s to save time and space. So 0 into 4 will be 0, and 0 into 81 will be, okay. Now we add negative 1 by 64. So when we add negative 1 by 64, we get negative 1 by 64, and to the right hand boundary point as well, we get 323 by 64. Okay. Now this is your g of x. So g of x comes out to be negative 1 by 64 and 323 upon 64. Now we have to find the range of fx. Okay, fx. We have to find the range of fx. In the beginning, you can see we have to find the range of fx. Our original expression is fx, and fx is equals to square root of g of x. So now we'll do what? We'll take the square root. Okay, we'll take the square root. This is creating a problem, a trouble for us, but don't worry, I'll handle it. Okay, so we have fx is equals to square root of gx. Now we take the square root of all the elements in the range of gx. But my dear friends, you see a negative sign here. Okay, let's represent g of x, the elements of the range of g of x. Let's represent them on the number line. So we have 0 here, and on the right, okay. So now this portion should be a little larger. This portion should be a little larger. Okay, this one, because the number line, it is extending from negative 1 by 64 to 323 upon 64. 323 upon 64 will be much far away from 0, and negative 1 by 64 will be very close to 0. So for taking the square root, we have to take only positive numbers of the number line. So we reject this portion. Okay, I'm talking about this portion. We reject this portion up till 0, and we have to take this portion from 0 to 323 by 64. Okay, so we take, I think it's not visible clearly, I'll just again 0 to 323 upon 64. Okay, so again we'll write gx 0 to 323 upon 64, and then we take the square root of gx. Okay, so when we take the square root, we take the square root of the left hand boundary point and the right hand boundary point as well. So the square root of 0 is 0, and the square root of 323 upon 64 is the square root of 323 upon 8. And this is our fx, and we did it. So the range comes out to be 0 to 323 upon 8. Okay, so that's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming video. See you all my lovely friends in my next upcoming videos with more exciting and a lot of awesome questions. Till then, bye bye, stay safe, and have a nice day.